Hi friends, my name is Milan. In this video, we learn about exercise 5.1. So let's start it with question number 1. First of all, read this question. Which of the following statements are true and which are false? Give reason for your answers. Okay, we need to write the answer true or false and we need to write the answers. Reasons. So first statement is only one line can pass through a single point. Only one line can pass through a single point. So this statement is false because from one point we can pass infinite number of lines, right? From one point we can pass infinite number of lines. That's why this statement is false. Here it is written only one line, okay? We can pass infinite number of line through the single point. So that's why this statement is false. Second, there are infinite number of lines which pass through two distinct points. From two distinct point we can pass only one line. From two distinct point we can pass only one line. So this statement is even false. Okay. Here it is written infinite number of lines. No, we can pass only one lines from two distinct point. That's why this statement is false. Okay. Given statement contradict the postulate 1 of the Euclid that assured that there is a unique line that passes through the two distinct points. Okay. Number 3. A terminated line can be produced indefinitely on both the sides. This is true statement postulate 3, right? 3 or 4. 3 otherwise 4. A terminated line can be produced indefinitely on both the sides. Okay, we can extend in both the direction. So this statement is true. If two circles are equal, then the radius are equal. It is even true statement, right? If two circle have only one dimension, it is radius, right? So if circles are same, then definitely its dimension are same. That means radius are same, right? So if two circles are equal, then the radius are equal. True. Number 5, if AB is equals to PQ and PQ is equals to XY, then AB is equals to XY. Okay, let's suppose if AB is equals to 5 centimeter, then PQ it is 5 centimeter, right? Because AB is equals to PQ. Now PQ is equals to XY. So PQ and XY have same measurement. PQ is 5 centimeter, so definitely XY is 5 centimeter. So alternately AB is equals to XY, right? Both have same measurement, right? So AB is equals to PQ and PQ is equals to XY. So definitely AB is equals to XY. So this is even true statement, right? After that, question number 2. Give definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? So first of all, parallel lines. Here we need to write the definition, right? And are there other terms that need to be defined first? What are they and how might you define them? So first of all, parallel lines. Now what is the definition of parallel lines? Two lines are said to be parallel when the perpendicular distance between these lines is always constant. Or we can say that the lines that never intersect each other are called as parallel lines. Okay, two definitions are there. If two lines do not intersect at anywhere, it is called parallel lines. Okay, if two lines does not intersect at anywhere, then it's called parallel lines. Otherwise, in parallel lines, perpendicular distance between them always remains the same. So we have total two definition for the parallel lines. First one is two lines are said to be parallel when the perpendicular distance between these lines is always constant. Okay, this is first definition. And second definition, we can say that the lines that never intersect each other are called as parallel lines. Okay, we need to define line first in order to define the parallel lines. That means if we want to write the definition of parallel lines, then here one term we have, it is line. So first of all we need to define the line. After that we can give the definition of parallel lines. Second is perpendicular lines. Okay, perpendicular lines, that means it makes 90-degree angle, right? So two lines are said to be perpendicular lines when the angle between these two lines is 90 degree. Very simple definition is there for the perpendicular line, right? If two lines are said to be perpendicular lines when angles between these two lines is 90 degree. Okay, we need to define line and angle in order to define the perpendicular lines. That means if we want to write the definition of perpendicular lines, so here we need to define lines and angles. So these are the terms that we need to define first. Third definition is line segment. Third definition is line segment. So what is the definition of line segment? A line of a fixed dimension between two given points is called a line segment. Right? Line segment always have fixed length, which we can measure by the instrument, otherwise scale. Okay, so line segment always have fixed distance. It cannot be extended in any direction. Okay, so a line of a fixed dimension between two given points is called as line segment. If we have two given points, then if we draw one line which join between these 2 points, so it is called a line segment. Okay, a line of fixed dimension between two given points is called as a line segment. We need to define line and points in order to define a line segment. Okay, here in the definition we use two terms. It is line and this points. Okay, then next one is radius of circle. Radius of circle. What is the definition of radius of circle? A line segment joined between the center of a circle and any point on the circle. Right, a line segment joined between center of circle and any point on the circle. Okay, all these are radius. So the distance of any point lying on the boundary of a circle from the center of the circle is called as radius of a circle. The distance of any point lying on the boundary of a circle. That means this is the boundary of circle, right? So if any point lies on the boundary of this circle and if we join that point with the center, so distance between this center and that point on the boundary line, that is called radius r. Okay, so distance of any point lying on the boundary of a circle from the center of circle is called as radius of circle. And here we need to define circle and center of circle. These two terms we need to define first before giving the definition of radius of circle, because in this definition we use these two terms, circle and center of circle. Right. The next one is square. Square is one type of quadrilateral, right? That these things we already learned in standard 8. Square is one type of quadrilateral in that all four sides are same and all four angles are same. Okay, all four sides are same and all four angles are same. It is called square. A quadrilateral with all four sides equal and all four angles of 90 degree is called as a square. If all the four angles are same, then definitely it have measurement 90 degree. Okay, so a quadrilateral with all four sides are equal and all four angles of 90 degree is called as a square. Many students do the mistake here. That means they just written that all four sides are same, but all four sides are same in square and in the rhombus even, but rhombus is not a square, right? So to specify the square, we need to write this full definition. All four sides are same and all four angles are same, otherwise 90 degree. It is called square. Okay, in quadrilateral. Now here we need to define term quadrilateral and angle in order to define a square. Okay, we can also write here sides. So quadrilateral and angles are the terms we need to define first. After that, question number 3. Consider the two postulates given below. Given any two distinct point A and B, there exists a third point C which is between A and B. Okay, given any two distinct point A and B, there exists a third point C which is between A and B. and second is there exist at least 3 points that are not on the same line. There exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulate? Explain. Total 3 questions are there. Do this postulate contain any undefined terms? Are this postulate consistent? Do they follow from Euclid's postulate? Explain. So our first answer is we are given with the following two postulates. Total two postulates are given here. That is written here. Given any two distinct point A and B, there exists a third point C which is in between A and B, and there exist at least 3 points that are not on the same line. So if we find the undefined terms, then we have two undefined terms. It is a point and line, right? So here we have two undefined terms, point and line. Undefined terms, that means we cannot give the proper definition, right? It is called undefined terms. For point and for line, we do not have any specific definition. So here undefined terms in the given postulate are point and line. After that, this postulate are consistent or not. The given postulate are consistent as they do not refer to similar situation and they refer to different situation. Okay, both this postulate give the different situation. In first condition, if A and B are 2 points are there, then definitely one point C which is lies between A and B. This is first postulate. And in second postulate, if we have 2 points A and B, then there exists at least one point which is outside the that is not linear with this 2 point. Okay, so these two postulates are different. In first postulate, there exists as point C which is lies between A and B, and in second postulate, C there exists at least one point which is not linear with these 2 points. Okay. We can also conclude that it is impossible to derive at any conclusion or any statement that contradicts any well-known axiom and postulate. Okay, we cannot give any axioms or postulate which contradict these statements. The two given postulates do not follow the postulate given by Euclid. Euclid's postulate are different and these two postulates are different. That means this postulate do not follow from the Euclid's postulate. Okay, Euclid's postulate are different than this. So the given postulate can be observed following from the axiom. Given two distinct points, there is a unique line that pass through them. Okay, so total 3 questions are there. First answer is undefined terms, points and line. Okay, then this postulate are consistent or not. So both postulate represent different situation. So both are consistent. Okay, after that, for a conclusion, we cannot give any contradicts. We cannot give any statement which contradicts the well-known axiom or postulate, and which these postulates does not follow the Euclid's postulate. Okay. So first answer is point and line, second one is consistent, and third is no. Okay, after that, question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. Explain by drawing the figure. We have one figure AB, a point C which is lies between A and B, and here it is given that AC is equal to BC. Okay, we need to prove AC is equal to half of AB. So first of all, an axiom of Euclid said that if equals are added to equals, the wholes are equal. So here it is given that AC is equal to BC, right? Here AC is equal to BC, which is given to you. Now if we add the equal things in both the side, that means AC. In both the side we can add AC, right? In both the side we can add equals. So in both the side we add the AC. Okay. Now AC plus AC, it's a 2AC, and here BC plus AC. BC plus AC, it's a AB, right? So AB is equals to 2AC. Right? And exam the Euclid said that things which are coincide with one another are equal to one another. Okay. Things which coincide with one another are equal to one another. That means BC plus AC, it forms AC, right? Coincides, because here we have A, here we have C, and here we have B. If we add these two things, so it forms AB, right? So AB is equal to BC plus AC. Now in place of BC plus AC, we can write this AB here, right? So AC plus AC is equal to AB, right? So AC plus AC is equal to AB. It means 2AC is equal to AB. But what we need to prove here, AC is equal to half of AB, right? And here we have 2AC is equal to AB. So in both the side, we can divide by 2, right? Because if we take half on both the side, then our answers are same. So here 2 cut, right? So AC is equal to here divided by 2, that means 1 by 2 AB, right? So in this way we can prove this. So here one more exam, things which are halves of the same things are equal to one another. If we take half on both the side, then even our answer is correct. Okay, here we get 2AC is equal to AB, so we can multiply in both the side half. We can take halves in both the sides, so 2 cut. So AC is equal to half of AB. Okay, so first of all, AC is equal to BC is given to you. In both the side we can add equals, right? It is AC, here 2AC, here coincide, so we can write AB. Now in both the side we can divide by 2, so 2 cut, AC is equal to half of AB. Okay. Then next, in the above equation, point C is called midpoint of line segment AB. Prove that every line segment has only one and only one midpoint. Okay. In above equation, point C is called midpoint of line segment AB. Prove that every line segment has one and only one midpoint. So here we can use the contradiction method. We need to prove that every line segment has only one and only one midpoint. Let us consider the given below line segment AB and assume that C and D are the midpoints of the line segment AB. Here we need to prove we have only one midpoint of given line segment, but we use the contradiction method. That's why we take two different points and we just say that C and D both are midpoint of AB. Okay, and we just prove our assumption is wrong. Okay, so we just take here C and D are 2 points which are the midpoints. So AC is equals to BC, right? Because C is midpoint, so AC is equals to BC. AC is equals to BC. Now in both the side we can add AC, right? Equals we can add on both the side. So from the figure we can say that BC plus AC is AB, right? Full AB. Means same thing that we used in previous question. So AC plus AC is equals to AB, right? So alternately 2AC is equals to AB, right? 2AC is equals to AB. Now same thing we need to use for the midpoint D, right? Same thing we need to use for the midpoint D. Here we have AB, here D is our midpoint. Now D is midpoint, so AD is equals to BD, right? AD is equals to BD. Now in both the side we can add the equals, that means AD, right? So here AD plus AD 2AD, and here BD plus AD, it's a full AB, right? Coincide. So now we can give half on both the sides. So here 2 cut. So AD is equals to half of AB. Otherwise we can write 2AD is equals to AB. Right. So same thing we need to use here from here AD is equals to BD, because D is also midpoint. In both the side we can add AD, right? So AD plus AD, this is AB. Now AD plus AD, it's a 2AD is equals to AB, equation number 4. Now we have two equation, one equation here and one equation here, right? So in this two equation what we have, 2AC is equals to AB and 2AD is equals to AB, right? Both are equals with the AB, so we can write like this, 2AC is equals to 2AD, right? We can put the value of AB. Now in both the side we can divide it by 2, we can take half, so 2 to cut, so alternately AC is equals to AD. It means point C and D are the same point. That means we do not have two different midpoint, but we have the same midpoint. Okay, here things which are halves of the same things are equal to one another, so we can divide by 2 in both the side. Okay, therefore we can conclude that assumption that we made previously is false. A line segment has only one and only one midpoint. Okay, here we take two different midpoint, but after at last what we get here, AC is equals to AD. That means point C and D are same. That means we have only one midpoint. Okay, initially what we assume, we just need to consider two points C and D. Both are midpoint of the line segment. First of all, consider C. So AC is equal to CB, then add AC on both the side. So AC plus AC, 2AC, and here AB, right? So 2AC is equal to AB. This is our one equation. Then second, D is also midpoint, so AD is equal to BD. Then add AD on both the side. So AD plus AD, it's a 2AD. Okay, and here DB plus AD, it's a AB, right? So here 2AD is equals to AB. Then we can compare that two equation. So we get 2AC is equals to 2AD. Now in both the side we can divide with 2. So 2 to cut. So alternately AC is equals to AD. That means your C and D points are same. That means you have only one midpoint. Okay. Now next question we just see in our next video. Okay. So here if you have any doubt, so write down in comment section. I will give you the answer. Thank you.